Hello friends, hello friends and dear students. I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 3 video on the chapter of linear equations in two variables where I will be solving another 10 conceptual problems based on the concept of solutions of linear equation that I have discussed in part 1. This video is part of the playlist CBSE Maths for class 9 following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends, and please subscribe to my channel and do not do not forget to press the bell icon so that you will be notified by my future videos. Okay. So the first question says that study the following two statements carefully and select the correct choice. The statement 1, S1, is saying that minus the ordered pair minus 1 comma 1 is a solution of the linear equation. Question is given. And statement 2 is if x equals to 3 and y equals to 7 by 2 is a solution of linear equation, then value of k is 17. The choices are only S1 is true, only S2 is true, both S1 and S2 are true, both S1 and S2 are false. So we have to verify whether the statements S1 and S2 are true or not. Okay. So if minus 1 and 1 is a solution of the linear equation, then the ordered pair minus 1 and 1 will satisfy this given linear equation, which means that if I substitute the x value of the solution in the equation and the y value of the solution in the equation LHS and RHS should be equal. Okay, so 3 by 2 x is minus 1 minus y is 1 by 3 is equal to minus 11 by 6. Let's see if this is true or not. More appropriately, it is better you have to LHS of the given linear equation. When we substitute the values of x and y from the given solution, it becomes this is equal to minus 3 by 2 minus 1 by 3, which is indeed minus 11 by 6, which is equal to the RHS. So this implies that S1, the statement S1 is true. Okay. Let's see the statement 2, x3 and y equals to 7 by 2. So let's see what is the LHS of the linear equation by substituting the value of x and y from the solution ordered pair. LHS is equal to k minus 3, x is 3 minus 2, y is 7 by 2. This should be equal to 0. Actually, we have to find the value of k for statement 2. Okay, so this implies we have k is equal to 7 plus 9, which is 16. 7 plus 9 is 16. So the value of k is 16, and it is the statement 2 is saying that the value of k is 17. So we can see this is not equals to 17. So we can see that S2, the statement S2 is false. This is a false statement. So definitely the correct choice will be S1 is true. Only so we see that only S1 is true. So the correct choice is A. A is the correct choice. Let's see the next problem. Question number 2. The equation y equals to 5 in two variables x and y can be written as okay. So whenever you are given, so let's say if you are given let's say linear equation in two variables, but one variable is missing. Let's say we have something like ax plus c equals to 0. Clearly we see the variable y is missing. So this kind of equation, if you are asked to write it as a linear equation in two variables, I can write it as ax, and for the y, I will write 0 multiplied by y and then plus c is equal to 0. Because 0 multiplied by y will eventually become 0. But in this format, at least I can see the variable y. Similarly, if the equation is given as, let's say, bx, by plus b equals to 0, where we see the variable x is missing, I can rewrite this equation in the as a linear equation in two variables x and y, so that both the variables x and y are visible as 0 into x plus by plus d is equal to 0. Okay, so in this problem, the given equation is y equals to 5, which means y minus 5 is equal to 0. It is not required. We have to see the choices, what choices are given. I can see the 5 is, in all the choices, the 5 is on the right hand, on the RHS only. So I can say 0 into x plus 1 y means 1 into y is equal to 5. So clearly, the correct choice is C. C is the correct choice. Let's see the next problem. The ordered pair a comma minus a can be the root of the linear equation. Can be the root of the linear equation. So from the ordered pair, what is the ordered pair as a solution? It is a minus a. This means that this means that if this then one possible linear equation that will be whose solution root can be a comma minus a, we can see can be that the value of y is the negative of here over. So this is y. This is the y value of the solution. This is the y value of the solution, and this is the x value of the solution. We clearly see that y is equal to negative of x. Minus a is negative of a. So just orally, just visually, we can say that this root a minus, any root of the form a minus a comma minus a, where instead of in the place of a you can consider any real value, then this kind of all these roots can be the solution of the linear equation y is equal to minus x. If I further simplify this, it will be y plus x is equal to 0. So clearly we see that y plus x equals to 0 should be the linear equation where a comma minus a can be a root. Now, what about the other choices? X minus y is equals to 0. Now, the ordered pair a minus a comma minus a will not satisfy x minus y is equal to 0. You can also verify that the ordered pair a comma minus a will not satisfy the linear equation x equals to minus a. Similarly, a comma minus a, this ordered pair will not satisfy y equals to a. So clearly, so one way of solving this problem is that you will check whether the ordered pair a minus in which of the linear equation given in all the choices is satisfied by the ordered pair a comma minus a. So in that way you can solve it. Otherwise, just seeing the pattern of the ordered pair, pattern of the values x values and y values of the ordered pair, I can see that the y minus a is negative of a. That is, the y value of the ordered pair is equal to negative of the x value of the ordered pair. So in that sense, I can say y equals to minus x. And if you simplify this equation y equals to minus x, you will have y plus x equals to 0. So A is the correct choice. Let's see the next problem. All roots or solutions of the equation are of the form. Okay. Now this is a little conceptual problem. How will you find, given a linear equation in x and y, how can you say what will be the form of all the solutions or roots? That is, what values can x and y take? The idea is that you see that in all the choices some constant m is used. By this, it means that instead of m, in the place of m, you can consider any real value. That is the meaning. if the choice says m comma 2m minus 9 by 5, this means that in any root of the given of the, if you consider m as the x value of m, if you consider m as the x value of a root of the given equation, then the y value of the root will be 2m minus 9 by 5. Okay, so the the way you solve is that you consider, let's say, y to be m. Since you see that m is in some of the choices, m is there in the y as y value, and m is also there as x values. In choice A and B, m is there as x value, and in choice C and D, m is there as y value. So what you do is you consider, let y equals to m. I am trying to find a root where the value of y is m. I am trying to find a root where the value of y is m. So what will be the value of x? Simply I will put the value of y as m in the equation and solve for x. So I have 5x plus twice m is equal to 9. This implies from here I will get x equals to 9 minus twice m by 5. Now you see, then I can say that m comma 9 minus 2m by 5 will be a root of the given equation. Now I have assumed m to be any real number. So obviously I can say that all roots of the given equation will be of the form m comma 9 minus 2m by 5, where m is any real number. Now you see if this exists in any of the choices or not. Clearly it exists. It is choice B. And since all of these multiple choice questions are single correct, then obviously B has to be the correct choice. Now, so I assumed y to be m. You can also do it in the other way, that is, let x is equals to m. Let x equals to m. I am trying to find a root where the value of x is m. So I have to find y. So I will put x, the value of x as m in the given equation, and solve for y. So what do I get? 5m plus 2y is equals to 9. From here I can solve for y as 9 minus 5m by 2. Clearly then m comma, oh I'm sorry, in the previous case I assumed y to be m. So this is not the ordered pair. The ordered pair is 9 minus 2m by 5 comma m. This will be a root. This will be, so all roots of the given equation can be of the form 9 minus 2m by 5 comma m. So the correct choice is actually not B but C. C is the correct choice. Now if I consider I'm trying to find the value of trying to find the root of the given equation, and let's say the x value is m. So what will be the value of y? So that it will be a root of the given equation. So I will put the value of x as m in the given equation and solve for y, and I get y equals to 9 minus 5m by 2. So now I can say that m comma 9 minus 5m by 2 will be a root of the given equation. And since m is any real number, it can be any real number, I can say any root, all roots of the given equation will be of the form m comma 9 minus 5m by 2. And you see this form is not given in any of the choices. So choice C is the correct choice. Let's see the next problem. Find m if 7 comma minus 3 is the solution of the linear equation y minus 3 by 7 is equal to m into x minus 2 by 7. Now this, you can see that this linear equation in x and y is not really looking good. It is not in the standard form. But whenever you are for solving this kind of problem, that you are given that a particular solution, a particular ordered pair is a solution of the given linear equation, and you have to find an unknown which in this problem is m, then there is no need to convert the given linear equation in the standard form. You just satisfy the solution or the ordered pair of the solution in the given linear equation. So what will I do? Since 7 comma minus 3 is the solution of the linear equation, that this ordered pair will satisfy the given linear equation. That means that substituting the values of x and y from the ordered pair, the LHS and RHS should be equal in the should be equal for the given linear equation. So I must have minus 3 minus 3 by 7 is equal to m, and x is 7 minus 2 by 7. I am satisfied. I am satisfying the ordered pair 7 comma minus 3 in the given linear equation. Okay, now I have to do a little bit of simplification. Minus 3 minus 3 minus 3 by 7 will be minus 24 by 7 is equal to m, and 7 minus 2 by 7 is 49 minus 2 is 49 minus 47 by 7. Okay, so I can multiply. So this is equal to 47 m by 7. Now I can multiply both the sides by 7, and I get minus 24 is equal to 47 m. Clearly, I will find the value of m as minus 24 divided by 47. So the value of m is minus 24 divided by 47. So the correct choice is B. B is the correct choice. Let's see the next problem. Question number 6. Okay. The linear equation x plus square root of 5y is equal to 0 has no solution, infinite many solutions, only one solution, only two solutions. Now clearly, the given we know that this is clearly a linear equation in two variables x and y, where we see that a is 1. We can see that a, if I compare this with the standard form ax plus by plus c equals to 0, a is 1, b is equals to root over 5, and c equals to 0. Even though it is not important to figure it out what is a, b, and c, the concept is that we know any a linear equation in two variables x and y always have infinite number of solutions. Always remember this. Has infinite number of solutions. So the form could be anything. It could be like if it could be even it could be like x. Even if one variable is missing, let's say ax plus b is equals to 0, then this is a linear. If I have to consider this to be a linear equation in two variables x and y, then also there will be infinite number of solutions, or infinite number of roots, or infinite number of ordered pairs which will satisfy this. Also, if the given equation is in the form, let's say by plus d equals to 0, x is missing, then also this is a, if I have to consider this as a linear equation in two variables x and y, then it will have infinite many solutions. Always remember, a linear equation in two variables x and y, irrespective of whether both the variables are present or not, whether one is missing or not, then it will have infinite number of solutions, as long as we will consider it as a linear equation in two variables x and y. So the correct choice is B. B is the correct choice. Let's see question number 10. Question number 7. Okay. It says, what will be the value of a minus b minus c whole to the power ab plus bc plus ca when the linear equation y equals to x is expressed in the form ax plus by plus c equals to 0. Okay, so basically we have to find the a, b, and c's of the linear equation y equals to x, and from there we have to find we have to evaluate this given exponential term expression. Okay, so the given linear equation is y equals to x. If I have to, this means that I can say x minus y is equals to 0. Clearly, we see that a is equals to 1, b is equals to minus 1, and c is equals to 0. Okay, so now what will be a minus b minus c whole raised to the power ab plus BC plus CA. So what is A? This implies what is A minus B minus C is equal to A is 1, B is minus 1 and C is 0. So this is 2. Okay. What is AB? AB is 1 multiplied by minus 1. This is minus 1. What is BC? BC is minus 1 multiplied by 0, which is 0. And also CA will be equal to 0 multiplied by 1, which is 0. So the term given expression will be A minus B minus C is 2 to the power AB plus BC plus CA. AB is minus 1, BC is 0, CA is 0. So this is 2 raised to the power minus 1, which is the reciprocal of 2, that is 1 by 2. So the correct choice is D. D is the correct choice. Let's see the next problem. If a comma 2 is a solution of the linear equation pi x plus 5y is equal to 54, then find k. It's a pretty straightforward question. We have solved a lot of questions like this. So k comma 2 is a solution of the given linear equation. That means the ordered pair k comma 2 must satisfy the given linear equation. So if it satisfies the given linear equation, we must have pi k plus 5 2 multiplied by 2 is equals to 54. Okay, now it is given that we have to take the value of pi as 22 by 7. So 22 by 7 multiplied by k plus 10 is equal to 54. This implies 22 k by 7 is equal to 44. Dividing both the sides by LHS and RHS by 22, I have k by 7 is equal to 2. This implies k is equals to 14. So the value of k is 14. So the correct choice is C. C is the correct choice. Now, if you find any difficulty or if you have any query, any step that I am applying to solve the problems that you are not understanding, always feel free to let me know in the comment section. I will do my best to address your query or to help you out in clarifying your doubts. Question number 9 says that if 1 comma k is a solution of the linear equation 2x plus y equals to 6, then all solutions of the linear equation kx minus y equals to k are of the form. If 1 comma k is a solution of the linear equation 2x plus y equals to 6, clearly from here we can easily find the value of k. And once we have found the value of k, then the second given equation, from the second given equation, we can again find all the the forms of the roots of a given equation. It is a very critical concept that from a given linear equation in two variables x and y, you must be able to create the form of all the roots. Okay, so 1 comma k is a solution of the linear equation 2x plus y equals to 6, which means 1 comma k, the ordered pair 1 comma k will satisfy the linear equation 2x plus y equals to 6. So I will get 2 multiplied by 1 plus k is equal to 6. This implies k is equal to 6 minus 2, which is equal to 4. Okay, so once we have found k, the second linear equation becomes 4x minus y is equal to 4. 4x minus y is equal to 4. Now, from this given linear equation in x and y, in variables x and y, how do we know? How do we know the form of all the roots? So you can consider let's say x, the value of x to be t or any other variable which will be a real number. Let x equals to t. Then I will solve for y by putting x equals to t in the given linear equation. That is, I am trying to, let's say, find the root whose x value is t, then what will be the y value of the root x, where t is any real number. So I have 4t minus y is equal to 4. This implies y is equal to 4t minus 4, 4t minus 4. Okay, so this implies that t comma 4t minus 4 is a root, should be a root of the of this of this equation. So I can say that all roots of this equation should be of the form t comma 4t minus 4, where t is any real number. But I do not see this form, that is t comma 4t minus 4, in any of the given choices. So what will I do is, so to find this form, I assume the value of x to be t. It didn't work out. So now what will I do is, I will assume, let's say the value of y is t, and I want to find the value of x, so that it will be a root of the given equation. So I will put the value of y as t in the given equation and solve for x. So I have 4x minus t is equals to 4. This implies x will be equals to 4 plus t by 4. So now I can say that 4 plus t by 4 comma t, this is a root of this given linear equation. In other hand, in another way, I can say that all roots of the given linear equation, the second linear equation, will be of the form 4 plus t by 4 comma t, where t is any real number. Then I can clearly see that we can this is given as choice A. So A is the correct choice. Let's see the last problem. Okay. If m comma 1 by m is a root of the linear equation x plus y equals to 3, where m is greater than 2, it is given that m is greater than 2, then the value of m minus 1 by m is. Now, okay, now by now you must be very, very clear that from the fact that m comma 1 by m is a root of the equation x plus y equals to 3, I can easily find out m. Now in this case, probably I will get a quadratic equation, but let's see what we get. The idea is that I will satisfy the ordered pair m comma 1 by m in the given linear equation x plus y equals to 3. That means that I will put the value of m as x, that is m, plus, and put the value of y as 1 by m. 1 by m is equal to 3. I have this. Now I have only this information. Now clearly, if I simplify the left hand side, I will get it will lead to a quadratic equation, which will not be that easy to. If you simplify this, I will get m square plus 1 by m is equal to 3. This implies if I do cross multiplication and bring everything on the left hand side, I will have m square minus 3m plus 1 is equal to 0. Now, since you are in class 9, I am not sure whether you are aware of solving a quadratic equation. So this is a quadratic equation in the variable m, and also one way of solving the quadratic equation is by factorizing the quadratic expression. That is the this quadratic expression by doing factorization, but it will not be easy to factorize. So there is another way, which is a method known as Siddharacharya, which I do not think you will study in class 9. So I'm not going to solve, I'm not going to simplify this m plus 1 by m equals to 3 and form a quadratic equation and solve that quadratic equation. No. I know 1 plus 1 by m is equal to 3. Now 1 plus 1 by m is a very interesting form because the problem has asked to find m minus 1 by m. Now from the chapter of algebraic identities and expressions, I hope you know what is the formula of a minus b whole square. So m minus 1 by m whole square is m plus 1 by m whole square minus 4 into m multiplied by 1 by m. That is, I have applied the formula that a minus b whole square is equals to a plus b whole square minus 4ab. I've applied this formula. So I got m minus 1 by m whole square equals to m plus 1 by m whole square minus 4 m into 1 by m. Because I know the value of m plus 1 by m, and I also see m multiplied by 1 by m will be 1. So I have m minus 1 by m whole square is equal to m plus 1 by m. We have got 3. So 3 square, and this is minus 4, which is equals to 9 minus 4, which is equal to 5, which is equal to 5. Now, whenever you have an equation of the form that some variable x square is equals to, let's say, k is some positive constant, obviously k is greater than 0, then the solution, then what will be the values of x and y? What will be the values of x that will satisfy x square is equal to k? X will be plus minus square root of k. Okay, so we can say that then m minus 1 by m should be equal to plus minus square root of 5. But it is given that the value of m is greater than 2. The value of m is greater than 2. The value of m is greater than 2. Okay, now, so we are getting two solution, that is m minus 1 by m could be square root of 5, or it could be negative of square root of 5. Now, we have to select one. Now, can m minus 1 by m be equal to negative of square root of 5? Can m minus 1 by m be negative if m is greater than 2? See, it is given m is greater than 2, m is greater than 2. This implies what will be, we can clearly say that 1 by m will be less than 1 by 2. If you have two positive numbers x and y, and if it is given, if you know that x is greater than y, where both x and y are some positive numbers, then if you take the reciprocal, the inequality sign, that is greater than inequality sign, will get reversed. It will be less than. This means 1 by x is less than 1 by y. So if m is greater than 2, then 1 by m will be less than half. Okay. So this implies m minus 1 by m will clearly be greater than 0. It cannot be. So m minus 1 by m cannot be negative 5. So m minus 1 by m is equal to square root of 5. So the correct choice is C. C is the correct choice. I hope solving these 10 problems will give you a more idea, clarity of how we are applying the concept of solution or root of a linear equation, all the form of all the roots and solution of a given linear equation, how to find an unknown value from a given root and of a linear equation, all these concepts by solving this problem. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I think I have solved enough problems on the concept of, in general, the concept of a linear equation in two variables and its solutions. The next video, I will start discussing about the graph of a linear equation in two variables. So please stay tuned for the upcoming videos. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.